Hello children, welcome back to my channel. Today we are going to discuss a very important concept in magnetism and from irodov. So that is force acting on a long paramagnetic metal placed at its end at the center of the current carrying circular coil. Assume one circular current carrying coil at the center. One end of the long paramagnetic rod has been placed and the other end is at the infinite. Assume at origin the magnetic field produced by the current carrying coil is B naught. At infinite the magnetic field is zero and assume the susceptibility of the paramagnetic material or rod is psi and the area of the circular cross section is S. For finding the total magnetic force acting on the rod, we assume one small element of thickness dx at a distance x from the center of the coil. Here, the element also act like a tiny magnetic dipole. The dipole moment of the coil as well as magnetic moment of the element both are acting in the same direction, and the coil produces magnetic field also in the same direction. We know the force acting on the element is minus dou u by dou x. We know the potential energy formula M vector dot B vector. M is the dipole moment of the element take outside, and we know dipole moment M for obtaining this. We know susceptibility is magnetization by magnetizing field. We know magnetization is equal to magnetic moment of that element by volume of the element. With this, we can write magnetic moment equal to psi into V into H. Plug in this value here, and we know the volume of the element is area of the circular cross section into length of the element, and the dx cancels, and integrate from x equal to 0 initial position to infinity, and to see the magnetic field limits initially. I mean, at the origin, magnetic field is B naught. At the power point, magnetic field is 0. At origin, total force acting on the rod is F left side. At infinity, element force is 0. If you plug in, you get one very wonderful result. With this, you can understand the force on the rod depends on nature of the material susceptibility, which have more susceptibility that will experience more forces, like the ferromagnetic materials, and also depends on the area of the cross section, and also depends on the external magnetic field produced by the current carrying coil. I hope you all understood very well. Thank you so much.